Yeah, till now we have seen all the classes of problems where we were counting something. So every finite automata we have seen till now is actually acting as a counter. In fact, it is a mod counter. Either so everything we did, either the string length or number of A's or number of B's, or even with binary numbers, ternary numbers, or any number system. Till now, everything we used is just for counting. Now let us look at some other class of problems. Even these problems are very important. Let us say I want to draw a DFA, minimal DFA, over sigma equal to a comma b, which accepts set of all strings starting with a. So I want to accept set of all strings which are going to start with a. First of all, anytime, see, whenever you see any problem, just first step is identify the language. So language is going to be, one is a, small a, because a is going to start with a, and then aa, because aa is going to start with a, and ab is going to start with a, and a, so on. First question is this finite or infinite? Infinite. So we don't know whether we will be able to give finite automata or not. But then let's try. So whenever the language is infinite, take the smallest possible string and give the skeleton. The skeleton has to accept the smallest possible string. The smallest possible string is a, and this is the skeleton which accepts a. Now decide if this is a DFA or not. This is not DFA because state a, we have shown what happens on small a, but we didn't show what happens on b, right? So whenever I get a in the beginning, it is okay, I can accept it. But if I get a b in the beginning, it means that the string is going to start with a b. So I don't care whatever comes after this. If the beginning is b, I should not accept it, which means if the string is going to start with b, I should never go to final state. So if the string is going to start with b, I am going to go to a state, some other state, and I will not accept anything from there. So if the string is going to start with b, I don't care what comes after it. I will never let such a string reach the final state. Therefore, this state is going to act as a dead state. Always remember, dead state is not a special state. It is one of the states, but we cannot reach the final state from the dead state. That is why we are calling it as dead state. Okay. Now, is this a DFA? For A, we have shown on small a and small b the transitions. For C, small a and small b, we have shown all the transitions. But capital B, we didn't show what happens if I get a. So what happens if I get a? After seeing a, if I get a, still the string is going to start with a. So once I see a in the beginning, whatever I get after it, I have to accept everything, which means once if I see any string which is starting with a, I don't care what I get after it, I'll keep on accepting it. Therefore, this is the DFA which accepts set of all strings starting with a.